Hey, what's up, guys? Welcome back to another weekly episode of Chemistry Uncovered. I hope that, wherever you guys are on this world, that this video finds you guys perfectly well, and that if you guys are not doing perfectly fine right now, I hope that this video makes you guys better by learning more chemistry, because chemistry has a way of bonding society, just like how chemical bonds are so important in this world. And that's why I'm talking about chemical bonds this week, right? Now, without further ado, this is Chemistry Uncovers episode number 7. So stay tuned for more weekly episodes. More weekly episodes, right? Now, before we talk about chemical bonds, I also want to mention that we have a flame test coming soon. If you guys haven't already checked out last week's video, go check that video out, because I explained the flame test lab that I have coming out in the next few weeks. So make sure to stay tuned for Flame Test Lab, because that's our first ever lab on Chemistry Uncovered, right? Now, before we talk about chemical bonds, I think it's important to talk about what the difference between molecules and compounds are, because when I started chemistry, I noticed that this is one of my main struggles. Like, what's the difference between a molecule and a compound? In simple terms, a molecule is two or more atoms bonded together, right? And a compound is two or more distinct atoms bonded together. So if you think about, a compound is a subset within a molecule, just like how a square is a subset within a rectangle. A compound can be a molecule, but not all molecules can be compounds, right? And in a molecule, in most cases, it's covalently bonded, in which they share electrons, just like how in this model they share an electron with this bond, right? For an ionic compound, it's a subset within a compound where it's two or more distinct atoms with the cation and the anion, the positive charged metal and the negatively charged non-metal, and it creates a crystalline lattice structure in solid form. It's not a molecule because the electrostatic forces, electrostatic mean the plus and minus attraction forces, there isn't a set number of ions, the crystalline lattice structure can be infinite, right? To be a molecule, you have to have the molecule is the smallest unit of holding two or more atoms together, but you can't have a small unit when the number of ions is infinite, right? And so a metallic compound is essentially metal cations with sea of anion electrons, right? So we can have a metal right here, and then pretend like these white circles are C's. It's this metal with a sea of electrons flowing around it. Right. Now, without further ado, chemical bonds. Chemical bonds, the simple definition is the forces that attract atoms to make molecules, ionic compounds, and metallic compounds, as we talked about in the previous slide. Right. Now there's three main different types of chemical bonds that make up the molecules, ionic compounds, metallic compounds. These three chemical bonds are ionic bonds, covalent bonds, and metallic bonds. To start off, you might be asking, what are ionic bonds, right? Ionic bonds is when a metal, by nature, a metal loses an electron, and it's when a metal donates an electron to the non-metal, because by nature, a non-metal gains an electron to become more stable, right? The metal is the cation in this case, and the non-metal is the anion in this case. And basically, these form an ionic compound. And the ionic bond created is between the electrostatic attraction, the plus-minus attraction between the cation and the anion. And this diagram to the bottom right kind of shows a good description of what it is, right? Next, we have covalent bonds. Covalent bonds is when two nonmetals, because by nature they both want to share electrons, they both gain electrons and become more stable. It's when they share that electron and the bond is created by the sharing electron. So for example, if we have hydrochloric acid right here, it's also the diagram in the bottom right. The H and the Cl, the hydrogen and the chloride, they both naturally want to gain an electron and become more stable. So they share that electron with this bond over here, and it creates a covalent molecule, right? Metallic bonds, and last but not least, we have metallic bonds. Metallic bonds is essentially when you have a metal atoms without nonmetals, right? Only metal atoms. By nature, metal atoms lose electrons and become more stable. So when you don't have any nonmetals to bond those electrons to, the delocalized electrons creates a sea of delocalized electrons just flowing around, right? And same thing as for an ionic compound. The bond creates an electrostatic attraction between the positively charged cation and a negatively charged anion, just like how in the magnet, there's a positively charged and a negative charge that connect. Same thing for cation and anion, they connect. And this forms a metallic compound. Again, going back to the definition of a compound is basically two or more distinct atoms bonding, and that's essentially what a metallic bond is with the cation and the anion. Right. Now, why do I teach chemical bonds, right? Just like how we can bond people together in society, just like how chemical bonds, covalent bonds, ionic bonds, metallic bonds are so important into how this world is structured. Just like how, H2O. H2O is the building block to society. There are covalent bonds in this H2O that makes it work, right? The end mission, as I will continue ending every single episode, is to make the world a better place. We can use chemical bonds to make the world a better place and use your resources to make the world a better place and to help the people around you. If you guys have more questions about chemical bonds, make sure to comment in the comment section below. If you guys want a live YouTube a YouTube live, then I can always stream a YouTube live and help you guys with any questions you have. So thank you. Peace out. See you guys next time.